Hi everybody, we're going to do a quick lesson today on lesson number 2, atomic numbers and atomic masses. So we've learned about atomic numbers and atomic masses before, but today we're going a bit more in depth about it. Now the big idea here is that atomic numbers and atomic masses are related to the nucleus of the atom. So we're going to talk about what subatomic particles are, where their charges, location, discoverer, and its mass. So let's begin. So the different subatomic particles we have depends on where they are. So for example, we talk about electron. Electron has a negative charge, while a proton has a positive charge and a neutron has zero charge. The location, it's in the orbits. It's in the orbital, while the proton neutron are found in the nucleus. The discoverers, well, remember electron was Thomson. The proton was Rutherford. But the neutron is Chadwick. Lastly, the masses. Well, if you talk about the electron's mass is tiny. It's approximately 9.11 times 10 to the negative 28 grams. While a proton is approximately 1.67 times 10 to the negative 24 grams. If you were to put into perspective, that's approximately 1,836 times larger, or heavier in this case, than more massive than the electron. The last one is neutron. The neutron, guess what, has approximately the same mass as the proton. So it's 10 to the negative 24 as well. But this time, instead of 1,836, it's 1,837 times more than electrons. Now, why is that one more than a proton? Well, you might remember back in Science 10, when a radioactive particle undergoes beta decay, a neutron turns into a proton electron. So that means that a proton plus electron gave you a neutron. So we're going to talk about the atomic number, and then we'll go on to mass. So what is atomic number? The atomic number represents the number of protons. So an example of that is, if you talk about hydrogen, hydrogen equals 1, which equals 1 proton. So every element is different because of its number of protons. Now, this is really important because you could have something that has the same number of protons, but different number of electrons. If it's different number of electrons, we call this an ion. When it's a different number of neutrons, we call this an isotope. So how do we read atomic number? Well, there's two different ways. This is called a standard atomic notation. It's a way to represent an atom talking about its isotope, for example, where X is a symbol, A is the mass, and Z is atomic number. Or sometimes you'll see it like this on a periodic table as well. Just always know the biggest thing here is the smaller number is the atomic number, while the larger number is the atomic mass. So how do we represent ions with these type of symbols? Well, to represent ions, well, first of all, we know in an atom, okay, number of protons equals number of electrons. That's why it's neutral. But when you remove an electron, it becomes a positive ion, which we call a cation. When you add an electron, it gains an electron, it becomes a negative ion because it gains something negative, and we call this an anion. And we can show this on the top right corner of our standard atomic notation. But there's a formula to always find the number of electrons. The number of electrons is always equal to the number of protons. Take away the net charge. So in this case, this sodium has 11 protons, and you take away plus 1, this sodium will have 10 electrons. Okay, how about atomic mass? What does that tell us? Well, atomic mass is a bit different. Atomic mass is the number of protons plus the number of neutrons. So for example, oxygen has equals, in this case, 8 protons plus 8 neutrons equals a mass of 16. That's its atomic mass. Well, if that's the case, we can always find the number of neutrons from this thing. So number of neutrons is equal to the atomic mass, take away the number of protons, which is atomic number. So, for example, if we look at, for example, the sodium, we see that sodium has a mass of 23, it has an atomic number of 11, it has 12 neutrons. So let's practice that out. Let's look at example 1 and let's talk about this. So let's find the number of protons, neutrons, and electrons from the following. Tin atom. So if you look at tin atom, tin, if we write this, I will write it as PNE, not the Pacific National Exhibition, but it is, in this case, going to be proton, neutrons, electrons. So if we look at this on our periodic table, we could see that tin, which is right here, has atomic mass about 119. So it has a mass of 119, and it has an atomic number of 50. So in this case, it means it has 50 protons. Okay, to find the number of electrons, it's tin atom, it's the same number. It's 50 electrons. Now if you want to be more specific, you can put P plus, N0, and E minus. The number of neutrons is 119, take away 50, that's 69 neutrons. Let's look at tin 4 ion. What this means is this is a +4 charge. Okay, so we're going to write P plus, N0, E minus. Protons doesn't change, neutrons doesn't change. What changes is electrons. Because it's a +4 charge, it lost 4 electrons. So in this case, it has 46 electrons. If you look at lead, we see a lead, so let's write PNE again, and then we'll just finish off the rest of them with PNE. Okay, lead atom. Well, lead is right here. It has atomic number of 207 and atomic mass of 207 and mass of 82. Mass of 207, number of 82. Okay, so that means its protons is 82, its electrons is 82, but its mass, if you take out your calculator, it'll be 207 take away 82, and that's 125 neutrons. So that's a lot of neutrons. Plutonium. Plutonium has a mass of, if you look at our periodic table, we see it has a mass of 244 and an atomic number of 94. So thus, it has 94 protons. It has 94 electrons. But in this case, neutrons, it only has 150. The last one we're going to talk about is gold. Gold is 197 mass, 79 number. So mass is 190, in this case 197, and number is equal to 79. So its atomic proton, it's 79. But let's get electrons. It's gold 2. It has a +2 charge. In this case, that means it lost 2 electrons. It is 77 electrons. Its neutrons, though, well, it's 197. Take away 79. That gives you a neutron number of 118. So this is your homework for this section. Now, page 146, numbers 13 to 19. So in this section of homework, you're going to be finding a lot of things regarding atomic mass and atomic number. So make sure you practice them well. As always, make sure you keep yourself safe and healthy. I'll see you soon.